2 to the x equals 7. Now you can make a guess, and I'd like you to start thinking in terms of estimating so that when your calculator hands you your answers, if you've hit the wrong button, you'll be more likely to realize it. Okay? But what does 2 squared equal?
4.
What does 2 cubed equal?
8.
If 7 is between 4 and 8, what do you think x is going to be? It's going to be between 2 and 3. My guess is closer to 3. Okay, so if I get anything other than a number between 2 and 3, I have done something wrong. All right, now I'm going to take the logarithm of both sides. Since I already know I'm using the calculator, which 2 logarithms do I have to choose from? ln and what else?
10.
Log base 10. Kara, pick one.
ln.
ln, natural log. Good. Okay, so I'm going to take the natural log of 2 to the x. That's equal to the natural log of 7. Taking the natural log of both sides. Saul, what's my verb for getting the exponent down? Whoosh. Thank you, Dean. I whoosh down the exponent. And now the natural log of 2 is just a number. Some ugly little number, lots of decimals, goes on forever. But I divide both sides by the natural log of 2. Anybody got that on the calculator yet? Okay, 2 plus 7. Yes, please heard that. Natural logs, ln 7, close.
2.8.
2.8. Did you call that?
I said 2.7.
All right. It's about 2.8 actually, because it's going to,
2.807.
Perfect. Good. Incidentally, this is another case where we've sort of reinvented or re-demonstrated the change of base rule. Going back a step, rewrite this statement so that it's a logarithm. How would you rewrite this statement so that it's a logarithm?
Log 2x equals log 7.
Almost. Log base 2 is correct. The base of the exponent is always the base of your logarithm. What's always the answer to a logarithm?
X.
The exponent. So in this case, it's going to be an x. So this is the same thing as log 2 base 7 equals x is the same thing as 2 to the x equals 7. No difference between those two. And if I gave you this and said, what's the value, you would use the change of base rule. Solving with logarithms is basically where the change of base rule came from. Log 2 base 7? Natural log of 7 divided by natural log of 2. Or log base 10 of 7 divided by log base 2.
Well, I think how do I find log 2 close parentheses 7?
Exactly wrong. You plug in log 7 close parentheses divide log 2.
Oh, is it the same equal to ln?
Yeah, ln works. Actually, change of base rule works for anything. Listen. Change of base rule actually works for anything. Like, this was also equal, Saul. This is also would be equal to, like, log base 50 of 7 over log base 50 of 2. It's just, there's kind of no, real quick, here back. It's just there's no real use to this because we don't have a log base 50 button on our calculator. Change of base rule works for anything. That becomes more useful, definitely in calculus. Okay, sort of an order of operation ones. I'll do one more. I'm sorry, no I won't. I will do 3 more.
Can we please practice the second method?
That one?
Yeah.
Um,
We might do all logarithms, but we have to do that one.
I'm not sure it'll come up.
Oh, okay, then why did you teach it?
Yeah, I'm not sure it'll come up on these 3 examples. I'll see what I can do. Maybe I'll work out some after I'm done taping. Maybe we can do a couple more like that. See, that second method only works if both bases are powers of the same number.
Oh,
And a lot of the problems won't be that nice. It won't be 2 and 8 or 4 and 8. It'll be 13 and 17 or something hideous. Speaking of which, okay, here's where you got to start thinking in terms of sort of an order of operations approach. 10 to the 2x minus 3 plus 4 equals 21. Guesses on my first step?
Minus 4.
Woo!
Minus 4.
Dean, I admire the passion of your request, but we're going to go with Saul's and subtract 4 from both sides.
Okay.
Okay, that's right. Get the thing with the exponent by itself first. And that's going to be 17. Now, Marissa, if 10 and 17 were both powers of anything I could think of, any whole number, 2, 4, 6, anything, I would use that method. And that'd be fastest. Since they're not, I have to pull out logarithms, and I'm taking log of both sides. We're going to need our calculator because that's 17 on the other side, and this base is 10. So what log do you think we should use? What base logarithm do you think we should use on both sides? Saul's got the question. Good. So that's log 10 2x minus 3 equals log 17. This lets me whoosh down the exponent, which I'm going to write in parentheses. What is log base 10 of 10?
100.
Not nothing, close.
1.
It's 10 to the what? It goes away is why you're thinking nothing, because it's 1. It's 10 to what power equals 10, so it's 1. So yeah, it does go away, but please don't confuse it with 0. Equals log 17. Now log 17,
Wait, how'd you get 3? Or what happened to the 10? You just
Log
dropped
10,
it
there's another 10, so they cancel each other out.
out? Yeah.
yeah, log base 10 of 10 is 1. Yeah. Okay, if I could still give one of these without a calculator, and here's what I'd expect your answer to look like. Okay? I'd expect you to add 3 to both sides. 2x equals log base 17 plus 3. And then we divide both sides by 2. Log base 10 of 17 plus 3 over 2. If you don't have a calculator, you stop there. But please understand that this is a number, not a variable. If you do have a calculator, you hit the log base 10 button on your calculator, find out what it is, and finish it from there.
0.65.
Is it?
0.6505. 0.65.
So it's 0.65. That makes sense. Should be somewhere. Really? It should be bigger than 1.
Log 17 plus 3 divided by 2.
Oh, you figured it all out. Thank you, Saul. So that's how much?